In just a few minutes, you'll learn how to build complex patterns in Fusion, reduce crashes when working with heavy geometry, and cut print time and filament usage by adjusting one simple setting. Something I wish I'd known when I started 3D printing. Start a sketch on the horizontal construction plane and create a center diameter circle at the origin. This defines the outer diameter. Convert it to a construction line with X, since it's only used as reference. Press S to finish the sketch using sketch shortcuts and keep your workflow fast without leaving the canvas. Create an offset plane from the edge of the circle. Set the distance to half the diameter, 50 mm if you are using my values. Yes, you could drive this with the user parameter, but to keep this tutorial focused and fast, we'll skip parameters here. Start a new sketch on the offset plane. Zoom in slightly, press L and draw a short line. The exact size doesn't matter, but 2 mm matches my setup. You should now have a construction circle, an offset plane, and a short line at the circle's edge. Press S to switch to the surface workspace and start a sweep. Surface modeling allows open profiles that solid modeling can't handle. Use the line as your profile and the center diameter circle as your path. Set the twist angle to 360 × 30 and don't hesitate to try different values while following the tutorial. Great! Your next task is to create a new sketch on the original construction plane. Then use Project to capture one of the wave-like edges. Make sure Projection Link is enabled so the sketch updates automatically if you change the underlying geometry. With the projected sketch in place, create a new offset plane slightly above the original construction plane. I'll set mine to 10 mm. Start a new sketch on this offset plane. Use Project again, but this time capture the opposite curves of the surface geometry compared to the previous sketch. If you're unsure which edge to select, temporarily hide the surface body. It's a quick way to double-check that you're projecting the correct part of the geometry. You should now have two purple projected curves from different areas of the surface, at different heights. The purple color indicates that they are linked and associative. Before moving on to the final steps, use the view cube to orbit the model and make sure everything looks correct. Next, extrude the two wave-like profiles 10 mm each in opposite directions. The goal here is to create reference geometry that we can connect to form the final pattern. We'll build the connecting geometry between these two thin surfaces, and by working with surfaces, we can smoothly blend everything together, which you'll see in the next step. Remember to save your project regularly and add a version description if you want to make it easy to roll back to a specific version later. Next, hide the surface body created by the sweep operation. This declutters the workspace and reduces the risk of misclicks. Switch to the surface loft command and create a loft between the profiles. Set the continuity to G1 tangency to get a smooth transition between the parts. Tangency settings control how smoothly one surface flows into another. With G1 tangency, Fusion ensures that the surfaces meet with a continuous direction, eliminating sharp edges and visible breaks. This is especially useful when modeling patterned or organic geometry, where smooth transitions improve both visual quality and 3D printability. Before creating multiple instances, you need to mirror this part to get a smooth overlap between each section. The construction plane you set up earlier works perfectly as the mirror plane, since it sits at the same height as the surface body. You can perform the mirror as a join operation if you want fewer bodies in the browser. Alternatively, set it to new body if you prefer to keep the parts separate, which can be useful if you want to assign different colors or appearances to different sections. In theory, you can patch the model, turn it into a solid and shell it from here, or even make the pattern thicker. In practice, with geometry this complex, Fusion can crash. That's exactly what happened in my case. A more stable workaround is to create a circle with a diameter of 90 mm inside the model. Extrude this circle both upward and downward. The exact distance doesn't matter as long as it exceeds the total height of the pattern. This cylinder will act as a boundary. In upcoming steps, we'll use it to fill the volume between the circle and the patterned geometry. I'll save the project again here since the next operations involve complex geometry. Next, patch the top and bottom of the patterned surface model. This closes the surface, which gives us more flexibility to develop the interior geometry. Because we're only working with a fraction of the final model, the computations stay much lighter than if we were operating on the full height, which would significantly increase geometric complexity. Next, we'll use boundary fill to create a solid interior of the model. Boundary fill lets you generate solid bodies by selecting enclosing surfaces and choosing the resulting volumetric cells, which makes it ideal for complex or organic geometry where traditional solid tools often fail. Select all surfaces that define the boundary of the interior, then choose the cells you want to fill. Switch to the top view to get a clearer overview of the available cells. Once confirmed, a new solid body appears in the browser. Hide the surrounding surface bodies to easily inspect the result. Everything looks good at this point. We'll come back to the bottom later, but for now we can leave it as is. This keeps the workflow simpler, faster, and more stable. We'll multiply this section with exact precision shortly, but before creating more instances, take the opportunity to assign an appearance. Press A to open the appearance dialog. Everything created downstream in the Fusion timeline will inherit the appearance from this original body. You can type part of the appearance name to search for it, which is much faster than typing the full name or browsing through the folders in the appearance library. Press S to open design shortcuts and select rectangular pattern. Use the blue Z-axis as the direction and set the spacing to 20 mm, which matches the height of the mirrored body. You now have the full height of the model. This is a good moment to save proactively, since adding fillets to the outer edge means editing complex geometry, and performance can vary depending on your computer's capacity. Activate Fillet with the F key and apply a 3 mm fillet to the inner edge. Then press F again and add a slightly smaller 1 mm fillet to the outer edge. These values strike a good balance between visual quality and printability, but you can always iterate and fine-tune them further than we do in this fast-paced prototype. The patched bottom is too wide, so to keep things simple, hide it using the V key and create a new patch that matches the inner diameter of the pen holder. Press E to extrude this patch 3 mm upward. Set the operation to join, so the new body inherits the existing appearance. With the model complete, let's look at a few important 3D printing setting comparisons you don't want to miss. before wrapping up with recommendations for other videos that cover workflows many people tend to overlook. In the first image, you can see how lowering the infill percentage significantly reduces 3D printing time. If you don't need the extra infill for strength or functional requirements, it's worth dialing this setting down. As the second image shows, lower infill also saves a substantial amount of filament, often several meters per print. If you enjoyed this tutorial, consider subscribing to the channel, dropping a like or a super thanks, or checking out the linked videos to learn more workflows that many people overlook. Happy 3D modeling, and I'll see you in the next video.